Okay, we did a video on CFD recently. Got a lot of comments about the fact that CFD is just too expensive to use for these sorts of projects. So Harley and I thought we would go through some of what we think are the really important design tools to use for doing your own cars. So this is going to be a bit like a tier list, but all of these tools that we're talking about, they're all pretty useful. So we're not going to be saying, you know, S tier through the bottom. We're just going to say absolutely essential, nice to have, and optional. And I think let's just start with the one that viewers asked the question about, CFD. Where would that sit on the list for you?
So for me, having an incredibly extensive experience utilizing CFD throughout my engineering career, I would put it at the bottom of the list.
Yeah, not that, like, that doesn't mean it's bad, that just means optional.
No, I think it's optional. Your core engineering principles are what's required to get whatever you're working at functional. So I would say short of designing an airplane or something with aerodynamics or fluid dynamics being the primary focus, yeah. I think it's probably an optional tool, particularly from the lens of a DIY enthusiast or even an engineer operating at home.
Yeah, I'd agree with that. I think it's definitely possible to create even a pretty decent aero package on a car, even something that produces some downforce, has decent balance, just through, I guess, application of a bit of knowledge and some testing. So build the car, get it out on track, do a bit of testing, a bit of wheel-tough testing and so on. I think if you're doing something like what we're doing with Project 171, even though it's optional, yeah, I was always going to use it. And we're going to put so much time into building the bodywork that if there's a tool that helps make sure that that time's going to be worth it, it's a pretty low cost. And this is where, look, as engineers, the cost of things like AirShaper is pretty cheap. You know, the idea that you could, for $1,000 a year, have a pretty decent runs, engineering software, pretty cheap.
He defines it as cheap, but remember our time is free.
But obviously if you're working at home in a home workshop, there's a lot of other things you can do. You know, $1,000, $2,000 can buy a lot of materials. So I think it depends on the project. So because we're trying to make a 50s style bodywork work, which really shouldn't actually produce downforce very well and not have a lot of yaw stability, we sort of need that tool a little bit more. But if we were doing something like a Lotus 7 style car or a fairly traditional shape, probably wouldn't worry. About it. So I think that's firmly down there and that optional, but really useful tool. I enjoyed using it.
Yeah, I think it's worth highlighting the frame of reference here as well. We're talking a general approach for an engineering project, not something specific to, say, 171, where things like a lot of these optional tools become not necessarily essential, but for us, they're tools that we will use despite a lower ranking on that list, perhaps.
So are there any tools that you think for you are just a lock-in essential?
Lots. Probably the most obvious one for me, being a slightly younger engineer, would be CAD. Yeah. I think it's very hard to get by from an engineering perspective in the modern day without access to that. Certainly drawing boards, pen and paper in the past were far more prevalent, but I think your CAD is essentially integrated at the ground floor with your engineering workflow all the way up to fabrication. So I would put it as an essential.
Actually, in the early stages of this project, I still had a drawing board, so I'm a little bit older than you. And when I was very young, I actually did a little bit of work in some drafting boards in engineering firms, and really got to see the transition from drafting boards through to CAD. And back then, the CAD was pretty ordinary. It was 2D stuff. It wasn't as good as the 3D stuff now.
SolidWorks was way more stable back then.
Yeah, had a lot less bugs.
Never crashed.
Never crashed. But I think, you know, hopping on that drawing board, I enjoy the process of drawing on the boards. It's really nice. So you get to just have that sort of tactile feeling, but the speed is not there. You know, so if you know exactly what you're after, or you've got a pretty good idea, you can get a drawing out pretty quick, something that you can go and take to the lathe, make something. But if you're exploring the speed of iteration on 3D CAD and, you know, parametric CAD, so when you can go back and change dimensions, it's just so much faster. You know, the reuse of drawings, the reuse of models, and the fact that when you're starting to work with manufacturers, you might be sending models out. I think it's clearly on the essential list, and you know, those that are still on drawing boards and still doing that, yeah, absolutely, you can design a car that way. But I think the workflow that you know, I've become used to and you've become used to, CAD's on the essential list.
Yeah, I think not that would even discount the use of something like a pen and paper. I think as a category in and of itself, it's probably still an essential in my mind.
Well, let's like add it. We'll add it in the list. Pen and paper is essential as well. You've got to sketch out your ideas.
You got to sketch out your ideas. It can be much faster and in the early stages of concept design even to quickly sketch something down and bounce an idea off somebody rather than trying to draw the lines of a Ferrari or a Porsche from a conceptual perspective in a parametric software.
Yeah, I think sitting at a CAD workstation where you've just got a notepad and pen beside it, drawing out sketches, that's a much faster way of working than try to create everything first go on the CAD.
For sure.
As far as software goes, what are your preferences for CAD software?
So the one that I was raised with was SolidWorks. But since coming into my professional career, I've had a little bit more exposure to some other packages. All good in their own regards. I think there's certain softwares that lend themselves to particular designs, more complicated assemblies, for example. You might go towards more of a Siemens sort of product.
Solid Edge?
Yeah, something like that. On the more budget-oriented side, you've got things like AutoCAD, which can be perfectly serviceable for somebody working at home or even small to medium sort of business. And I've used another package called Creo in another life designing truck bodies, which I found to be quite good as well.
Yeah, look, I'm the same. I think I really like SolidWorks. I think when I was going through uni, we were working on Solid Edge. I've used Fusion 360, Inventor. I use that in the company. And I actually find they're all pretty much the same. You can do most things with it, and most of the software is going to annoy you in some way. So, Inventor was fantastic. Well, at least when I was using it, it was fantastic when you're doing weldments, and SolidWorks wasn't as good. It's a bit better now. Surfacing in SolidWorks isn't very fun. I've heard that's pretty decent in Fusion 360. So you're going to have some pluses and minuses, but pretty much we could just put CAD in one box and say, you can do it. But I think one of the problems there is this stuff is super accessible when you're a student, and as soon as you have to go out and pay for it yourself, it becomes really expensive. So if you're an engineer working with this stuff and you have access to it, you can use a pretty cool CAD. But if you're a hobbyist or doing this straight at home, I don't even know what, Solid Edge I think has a good deal.
Well, SolidWorks, you can get a hobbyist license now for about $160 a year, I think. That's fairly accessible for the average person.
Yeah. And I think Fusion 360 started with really good accessibility, but it's got worse.
Sort of moved away from that now.
Yeah, there's a really good spot there, and I'm sure somebody as viewers use something like FreeCAD or something like that. No real experience.
SketchUp.
Hey, SketchUp's got a fair bit of power. I think that I've seen some pretty amazing projects in SketchUp that I was like, no way would I ever try to do those in SketchUp, but no, go for it.
I think if you're just learning, there's no reason not to touch it. It's a lot better than a pen and paper for your basic sort of DXFs and things like that.
Yeah, and you don't need to go to absolute full detail with every component you're measuring. Or drawing up, we probably go to a little bit more detail than is actually needed, but you only need as much information to actually do the manufacturing.
Following on from CAD, the next logical one for me would be FEA. Where do you think that might sit?
So I think we're talking structural FEA.
Structural FEA.
Yeah, so for me, I think I would actually have it as a nice to have. So when I did my uni, I actually hadn't done any FEA by the time I finished my undergraduate. It just wasn't a tool we used. So we got pretty handy at doing hand calcs and I guess taking those hand calcs into Excel or some sort of program. And it's amazing how much you can design just by doing those calcs. And sometimes you just go, okay, we're just going to overbuild this. We're going to make this far stronger than it needs to be. Healthy safety factors. You can get a long way. And actually a lot of the components you design around brackets and things like that, you just don't need it. You just don't need the FEA at all. That being said, I'm going to be using FEA on Project 171 for sure, because we're going to be designing uprights and things like that. I don't know, what are your thoughts?
I think I mostly agree. It depends on the lens that you come at it from. So from a speed and workflow perspective, I think it's an essential. So if I were to use it professionally in my workplace, it would be certainly an essential versus something like a hand calculation. Similar to you, most of my university career was very hand calc heavy, which I'm very grateful for actually, because it gives you a strong foundation to kind of understand those results. I would say almost certainly in a hobbyist environment, 80-20 rule probably goes down to hand calcs for something like this, with your CAD being, the essential.
It can speed it up, I think, and it's just really another difference between working in an engineering job versus doing this at home. So if you're in that engineering field, FEA just speeds things up so much that you just go, no, this is essential. We wouldn't do these structures without it. The danger of these tools when you're starting to use them without having used them quite a bit is it's really quick to get the wrong answer as well. So you put the wrong boundary conditions in, or your meshing's not quite right. There's a lot of ways to misread.
The pictures always look pretty though.
Yeah, if it's red, it's failing. If it's blue, it's good. No, it's actually very far from that. And we got caught out once. So we were doing some brake disc design, and we're using a grey nodular cast iron. And most of the time when you're doing stress calcs, you're just looking at von Mises stresses. So that's actually a combination of the overall stress. It doesn't give you an idea of what's in tension, what's in compression. And the issue with the cast iron parts is they can't be loaded in tension. So you need to be designing the compression, and we actually had an area that was under tension, and we got cracks. So all of those discs were useless. We had to redesign them, and caught it in time, thankfully, but not really caught us out. And that was after having a bit of experience with that software. So you've got to be careful.
Garbage in, garbage out applies everywhere, unfortunately.
Yeah, they're all too closely to this project. So we got done CFD, we're done FEA, CAD, and pen and paper. Let's get to the hand calcs. So hand calcs will say at some point you're going to be doing some. What about we take them into a spreadsheet? Surely a spreadsheet is essential.
I think for me, a spreadsheet is essential. It sits up there, probably even above CAD. In terms of the importance of that. You can do a lot with the spreadsheet. You can design an entire car with a spreadsheet if you have the patience to do so. So I would say both in my professional working life and as a hobbyist, that they're both incredibly invaluable, essential tools.
Yeah, I don't think there's an engineer alive that hasn't, that's working at the moment that hasn't been both a big user of spreadsheets and super frustrated with them at the same time. So sometimes getting them to do what you want can be a bit tricky, but having reusable calcs, super valuable, and seeing relationships between different variables.
If you have to run numbers and you have to iterate on a particular design, you want to see what happens when you change a wall thickness or move a point. There's no faster way than to use Excel.
Yeah, and I've seen full geometry calculators. I'd still be using Excel to do load calculations, so calculate loads on wheels and so on. And I've seen full lap time simulations done in Excel. It's really quite powerful. So I definitely put it up there.
Yeah, I'd agree. I think once you move into something more computationally heavy, you're better off leaning more into some of your more programmatic tools, something like a MATLAB or an Octave.
Well, that's a good one. Okay, so let's say programmatic tools. So we're going to say like MATLAB or the free version Octave. You use that. Python's got pretty good libraries. I really haven't used much Python. I'm old school in programming. I'm at a university, so we get MATLAB for free. Well, they pay for it. I get to use it for free. Where would we sit that? Is that I don't feel that's essential.
No, I think once you're getting to that stage, it's a nice to have for me. It's possibly even optional depending on what you're doing. You can do 90% of what we're doing here without touching a single line of code. That said, for our workflows and for my workflow personally, it's got to be a nice to have, just because of the efficiency that I can gain personally by using it. But I think in a broad sense, it's probably an optional.
Yeah, I think for me it's an optional. And I say this as somebody that does a fair bit of programming. And we showed videos where we've done the kinematics using MATLAB. No, I would put it as optional. There's almost nothing that I would do in MATLAB or any of the programming languages from a calculation point of view that I couldn't, with a bit of effort, do in a spreadsheet.
Yep.
So if I had to choose spreadsheet or MATLAB, and you can only have one, be a spreadsheet for sure, and you could do just about anything. If often I'm only using things like these programming languages to just make automate tasks a little bit easier, not having to run macros, because I hate programming macros.
I avoid macros like the plague.
Yeah, so for me, that's an optional, and you could go a long way without doing it. If somebody was building a car, I'd say absolutely learn CAD. Really, that's an essential, and it's handy to learn some of these other calculation methods. But I wouldn't encourage somebody to learn how to program.
Not in the world of AI.
Okay, we're going to have to mention it. AI, and by AI, look, any of the large language models. So Claude or Chat. It's Claude GPT. I don't even know what's what.
No, Claude is a separate model. GPT is run by OpenAI.
Yeah, for me, I just use them as a search engine. I don't do as much coding through them. So for me, AI is no. I sometimes think it takes some of the enjoyment out. I do use it to help some of the research stuff. It's just an advanced search engine. But what about you? You use it a lot more.
I do. I would love to put it in the essential tier, but I don't think I could do that with a straight face. That would be entirely based on my use cases for it. Mainly for the productivity gains. Everything that we've mentioned can be done without it. Obviously, we operated for many years without any kind of LLMs supporting our workflows. But for the efficiency gains that can be had when the tools are used effectively and in a narrow bound, I think that it sits within that nice to have. That said, it's incredibly easy to misuse them and get bad results. So the garbage in, garbage out analogy applies. So for that reason alone, I think, look, probably it ends up in the optional.
Yeah, I like using it for tutorials. So if we were talking about this before the camera was rolling, is if I'm using a piece of software I don't use very often, I might just have AI open and just say, how do you do this? How do you do this particular process? And it just speeds it up. But anytime I've gone and looked at real particular knowledge around vehicle dynamics or cars, it's just fed with garbage. And so much of it is actually wrong and on the surface looks right, that I think you can have a lot of fun doing these cars and just ignore AI entirely.
I think that's true, yeah.
So one of the things we haven't covered yet too much on the channel is, I guess, the project management. So how do you, our cars are a really big project. There's so many things to design. There's so many things to order. There's so many things to make. If you're building a kit, even that's complicated. Even if you start with something that is a kit car and you're putting it together, that's a big task. There's a lot of organization. And obviously when we work in engineering, sometimes we're using these project management tools. So where do you sit things like the project management tools, like a Microsoft project or Asana or things like that?
I think I would start with a bit of an analogy, which is if you ask any person who has a project car at home how long it'll be until the car is finished, what's the standard answer?
It'll be done by the end of the year.
Done by the end of the year. And next year?
Yeah, done by the end of the year.
Still done by the end of the year.
Yeah. So, if we're honest, they're never done, right?
So I think it's a bit of a loaded question as a project car owner myself, who's perpetually working on it. But I think yes, valuable tool. Probably in the nice to haves, just on the basis that you can achieve the same outcome without planning tools. It just might take you a little bit longer.
Yeah, I think for me this is another one that a spreadsheet can do. So I've created tracking things on spreadsheets, and I actually find Microsoft Project and those sorts of things. I'm not a power user of any of those sort of things, and anytime I'm going to them, I spend almost more time in trying to wrangle them to get something useful out of them than I actually benefit from the results. So I'm very big on these sorts of projects as being very light. on the
I think a
project
basic
management.
Gantt covers most of
Yeah.
the requirements that anyone might need. It often helps with your own understanding of your workflow as well. This and then this and then this, or this and this, and that might actually help you to get across the line a bit sooner.
I reckon the biggest advantage of these project management things is just them being a list. You know, just a list of these are all the things you need to do, and making sure you're not forgetting. So anytime you think of something, you go, oh, I've actually got to do that. You just chuck it in a tool, or you chuck it in a spreadsheet, and you can go, okay, I'll tick that off. And just an estimate of how long things are actually taking. So, you know, these projects, you know, you said, when's the project going to be done? I think we'll sit together and we'll do, you know, some of the mock-up, and we'll think, oh, how much are we going to get done tonight? And you reach the end of the night and you go, we had fun, but I don't know that we got everything done that we wanted to get done.
Your estimates are always optimistic,
Yeah.
shall we say.
No, as a rule of pi, everything takes 3.14 times as long as you expect it to be.
And that carries through to professional project management as well.
Yeah, I think, and that's when you cross over to engineering, multidisciplinary teams. You're not just tracking engineers. You've got a lot of logistics involved. I think that's where your project management tools really start to shine. But if you've got a small group of people on something, I think you can get away with very light tools, and a spreadsheet's fine. So for me, optional, and like I'm using it only because I've developed something before. The next group of design tools, I don't know if we're going to call them design tools, but I think they are. They're about prototyping. So I reckon if we kick off with additive manufacture, so 3D printing, and we'll just say plastic, FDM, 3D printing. Where do you think that sits?
So again, for me, I think it's probably an essential, because the difference between somebody who can manufacture a part and put it on, even if it's non-functional, and somebody who can't, at the end of that project is meaningfully different for me in terms of the outcome that you can achieve from a design perspective. So I think it's probably an essential. Not to say that an engineer couldn't get a by without it, but I think if you contextualize it in today's day and age, where something like CAD is essential, I think taken hand in hand with that is 3D printing. So you've got your design tool, you're following through to the next layer of your process, which is naturally producing a part. Somewhere between this and fabricating the part out of steel is something like 3D printing.
Yeah, look, the first time I started using 3D printers was when they were, you know, quite expensive, the FDM machines. And it was really good to be able to prototype things quickly. You know, whatever you can think of, you can pretty much make. And I actually think the plastic 3D printers are probably the more valuable 3D printers. Like 3D printing in metal is really cool, but I think it's more specific, more isolated, the use of those. I think for me, something crosses over to the essential when they save you more money than they cost. And when you can get a really decent 3D printer now for under 500 Australian, and the material is, you know, less than $30 a litre, the number of times that, you know, we're building cars and we've saved thousands because we haven't made a mistake, because we were able to prototype something, they just pay for themselves.
They do.
Yeah, one mistake and this thing has paid for itself, and it's a useful way to be able to judge size, do mock-ups.
Not even mock-ups, final assemblies can be made of 3D printed parts in
Yeah,
non-essential
actual parts,
locations.
Yeah,
So
it crosses over. It's not just a design tool. It can actually be final use parts in low loads, use in general manufacturing and molds and so on. So I think that technology has matured to a point where I just say it's essential. And when we're doing student projects at uni now, all of them involve prototyping, and we just treat it as free. It's as just like having a paper printer now. It's amazed me how quickly that technology has become integrated in that design phase. So that one might be a bit controversial. You know, I think if you haven't been using 3D printers or haven't had those, like, I'd highly recommend it. It's fantastic to muck around with. They do a lot more than just print toys. So I think if CAD's in the essential, which I think it is, yeah, I'd agree. 3D printing for me is an essential development. So
agreed.
if we're looking at prototyping, where do we sit with just, I guess, general fabrication tools? So you're building a car and you want to just quickly put some mock-up together and you're starting to fabricate things. We're going to take hand tools and things like that as a given, so it's just some basic working tools, but a bit more the next level. So we're fabricating, we've got maybe a TIG welder.
CNC machine.
Well, I think let's go to CNC after, but just fabrication. So we've got the ability to maybe bend some metal, weld some stuff together in the design process. So, what are your thoughts about that?
I think it sits in the nice to have category, mostly because you can achieve the same result in a similar time frame with money.
Yeah.
And it's additional skill, it's additional capital that you have to invest. It's not something like a 3D printer where you can spend $300. For people like you and I, we happen to develop those skill sets over extended periods of time.
You more than me. I'm not that great a
Perhaps
fabricator.
myself more so than you
Yeah.
in the case of TIG welding, but you get my drift.
Yeah.
It's not a given for an engineering project, and it can be solved with a little bit of careful foresight through things like 3D printing, where you might send your upright out for manufacture or elsewhere rather than producing it in-house.
Yeah, I think you've got to have some skills are essential and some skills you're going to outsource. Like if you want to do these projects in any seriously short amount of time, especially if it's a design and build, you're not putting together something that somebody else has fabricated. So if you're getting a chassis off the shelf or some sort of kit car, a lot of that work's already been done. You've got to involve other people. You can't have all of these skills. I think it's a nice to have as well, but I would say what you do need is some ability to do sort of mock-ups and size things. So, maybe beyond the 3D printers, just be able to, what we've done. So we've made a mock-up just using MDF, putting it together. That's been really valuable in the design phase. That's not building the car, that's just actually building something to get an idea of dimension.
And I think once you get to the stage of, say, fabricating steel weldments or machining components, it doesn't matter what path of workflow you take, it's going to cost you some money.
Yeah.
You're not going to save a huge amount of money. You might save some time, but the costs start to climb once you get to that stage, versus something like 3D printing where you can think an idea up and produce it in half an hour.
They are valuable tools though, valuable skills. If you've got fabrication skills, why wouldn't you use them in that design process? Why wouldn't you mock things up? We would do that with the race car chassis. We would tack something together fairly quickly, and in an afternoon you get a really good idea of what you're working with. But it's a nice to have at the design phase, and then maybe if you're going to take that manufacturer on, you make an investment. But yeah, there's a lot of equipment, which is sort of, I guess, leads on to the last one we had on the list, which is, I guess, CNC equipment. So this is now trying to take some of the machining and automating some of that. This could be anything from a CNC mill, which could be quite expensive but really very cool, CNC lathes, or what we've put together with a CNC router. Where do you sit on that?
Well, I think the requirement of the fabrication or the CNC slash routing is an essential. How you get there is where the question mark lies. I don't think you can put it as an essential for the hobbyist to be producing CNC routers and mills and lathes that they make all their parts with at home workshop level. And I think options like First Part in China for things like CNCing has come along to the point now where it's not even necessarily cheaper to produce it in-house. So I think probably a nice to have again. You can certainly get by without it in terms of capacity, especially if you have a printer.
Yeah, I think for me it's even lower. It's an optional, and I took some effort to put together a CNC router. We've just got that running recently and just started to cut out parts for the mock-up. And in the end, we're hoping it's going to use to do some of the body work. And like over the moon, like it's a great tool. It now cuts really well. It wasn't that great the first couple of times we were using it.
Some fires.
Yeah, but it works really well now. But it was a pretty big investment, and actually picked up some of the parts for that like almost a decade ago. So it was just a project that was sitting in the background, and I actually had to ask the question, is it worth finishing this so we can use it as a tool, or just abandoning the project and just getting on with manufacture? I'm glad I put it together, but like if someone is designing a car, I'd be, no, don't put together a CNC. If you've got one, that's
not
great.
for that purpose.
No. So I think that's our list of what we consider design tools for putting a car together. Some of those are going to be sort of mocking things up so you get a real life idea of what the objects are. So if you've got any disagreements with where we put, which I'm sure some people will, or we've missed something out, we're racking our brains.
Please keep them to yourself.
Yeah, please make a comment and then we can answer and go, oh yeah, missed that one, obvious, that was a good comment. So please comment on that. On your way to subscribing, I think, if you're watching this, if you're not already subscribed.
Hit that notification bell.
Yeah, absolutely. And that's right, you got to, otherwise they don't tell you the videos, they keep feeding you garbage.
None of that AI slop.
And we're going to answer a few viewer questions or respond to a few viewer comments. And there was a bit of a one on one of the aero videos, which was from Quadra Cone. It's wild that you don't have a front splitter, air dam, and radiator duct and rear wing and spoiler. So basically a full aero car, like a high performance aero car, high performance downforce. And I responded, no, it's a road car, it's not a race car, it's going to be a 1950s sports car. And the comment was, choosing nostalgic looks over performance will never make sense to me. Good luck though. What are your thoughts about that?
Well, I think if you follow that argument through to its conclusion, you end up with a Model 3 with the performance package, right?
Yeah.
So I guess just to flesh out my point in a little bit more detail, performance, there are different metrics by which you might measure that.
Yeah.
And this car and the design of this car isn't aimed towards peak performance in every aspect. It's aimed to be a nimble, light, comfortable, road-going sports car with a nostalgic theme. And anyone who's driven a car from, say, the early 2000s or earlier will know that the feel of driving a car like that is very different to what you would see on, say, a modern car. Even a modern petrol-powered car with high performance, something like a GTR. So replicating that experience whilst going with the highest performance vehicle that you could possibly design in that format, the two things are incompatible with one another. So all that to say that the car that he's talking about is not the car that we're building.
Yeah, and it's a tough one because you're deliberately making something that is not as high performance or from a vehicle dynamics point of view, as good as you can make it. And why would you do that? And I don't know, the most fun I've ever had on anything with four wheels was a low-powered go-kart in the rain, hooking around cones that were set up on a track. It was just loose, it was fun, it wasn't fast, it wasn't a high performance, it was just a lot of fun. So I think there is a case that too much grip can actually be a little bit less fun. But look, each to their own. I think that if you want to go and build something that's as high aerodynamic performance as you can, that's great. I mean, that's largely what these supercar manufacturers are doing. Extreme
performance and playfulness don't really go together, particularly on the road, do they?
Well, yeah, I think an MX-5, if you've owned anything like that.
My GR86.
GR86, they're great cars. They're not high downforce cars. They're a lot of fun to drive. And I don't think you hop in one of those and go, I wish it was something else. You just appreciate it for what it is. And if it's an MX-5, you usually appreciate it and then move it on once you need a bit more power. But yeah, I don't really have any other answer apart from that, is that we're not going for out and out performance.
Yeah, buy a Model 3.
No, thanks. Okay, on the aero theme, so we had Tom Warren. You've done a little bit of work with Tom.
I know Tom.
Yeah, he's a great guy. Loved his review.
Yeah.
Pulled out some stuff that I wasn't expecting. One of the questions here from Jay Athers was, how would the engine and gearbox placement interfere with the diffuser profile changes that Tom suggested? And we'd love to hear which of the changes you plan to incorporate and which are not in scope, and see a rerun of the air shaper analysis. What did you think of Tom's analysis of the car?
Well, my experience with aero guys has always been that if they could, they would eliminate the powertrain entirely.
And the driver.
And the driver. And probably even the chassis, if they could, in favour of surfaces with wings on them.
Yeah.
So I think there's always a happy compromise to be made. In terms of Tom's suggestions specifically, I think there's some features that can be incorporated into the design of the car without compromising its overall, what would you say, feel
Yeah.
or intention.
Well, I think when I did the original video on the aerodynamics, I was getting a first run in it. It was a first pass, seeing how it goes, and I was largely focused on the airflow over the top of the car and really just noise, like what was coming off the windscreen, what was going through the radiator. And if you go back and watch that video, I sort of didn't really show the underside of the car. I was sort of hiding it because I hadn't put a lot of detail in. And as soon as Tom goes through, straight to the underside of the car, immediately looking at all the mistakes I made, and you just go, oh, this is great. I've just focused on the wrong things. Thank you very much, Tom. I think the biggest issue with the diffuser section is probably not dodging around the engine and gearbox, because even though it's a flat 4 that we're looking to do, where the width of the engine is, it's not far behind where the drivers are. So you're already wide in the car, and then it narrows up, because it's the arrangement of where the gearbox is, it narrows up around the gearbox quite narrow, so there's space there for the diffuser. The bigger issue will be the lower wishbones, so them poking through the diffuser, and so I'm not sure. I've got to go back to the model. But pretty much everything that Tom suggested, we're going to try and implement. So we're going to want to do that run again with some of those changes. And we've still got other things to look at. So we want to look at your stability. So far, it's only the one analysis. It's in a straight ahead case. We want to have a look at that in your... but I thought that was really valuable. That's why I wanted to share it. Tom had some really good insight. And when you see somebody that just lives and breathes aerodynamics, I mean, we all live and breathe air, but when you're in that aerodynamic space, they just look at the project a bit differently. And I thought it was really valuable. So I hope you enjoyed it.
They're a different breed, aero guys, aren't they?
Absolutely. 100%.
100%. Yeah, awesome. Cool as.
Oh, yeah, I'm not going to pull up any particular comment on this, but because we copped a lot of comments around this when it came to the mass location, there was a bit of talk about, oh, you forgot to talk about the polar moment of inertia. So you forgot to talk about your inertia and the effects of things. Look, it's just trying to break these topics and these vehicle dynamics topics up into small, sort of digestible videos. It's really hard to cover everything. So we're definitely not suggesting it's not important. And I think there's aspects of the design where that's really clear that we've taken that into account. Mm-hmm. So, you know, we've got the engine really close to the drivers, and so it's a very short car. What do you think? Do you think, if we're looking at this, that it's more important that we get the center of mass right where we want it, or we want to make sure this car is pretty quick to rotate, so a small inertia?
Well, I think you're the person that should be answering that question, but I'll do my very best, Dr. Kevin. So I think low mass is probably the top of the list for me.
If you've got low mass, you're going to have low inertia.
You're going to have low inertia anyway. In a car that has low mass, you're going to struggle to be placing, huge mass outside of your sort of the center of your car. So you're going to have that low polar moment of inertia in any case. You mentioned the engine; it's fairly close to the driver's back. The driver fairly close to the center of the vehicle. Even things like the chassis concentrate a lot of their weight in that center area. Yeah. So I think the two kind of go hand in hand, short of, say, ballasting to change that dynamic, which is a thing that is actually done in certain cases to affect that polar moment of inertia and in turn the way that the vehicle might let go. I think you get the best of both worlds by making the car light, would be my answer.
Yeah, I think there's only really one. When you're building these small cars, two-seater, there's not really any luggage space or anything like that in there. You're already a small light car. You're already going to turn pretty rapid. The only real decision you've got is, are you going to make that a front-engine car, or are you going to make that a mid-engine car? So if it's a front-engine car, you've moved the masses of the driver and the engine further apart from each other, so your moment of inertia in yours is going to go up. So it's going to be slightly more stable. If you've gone a mid-engine car, which is what we've done, you're putting the drivers and the engine about as close together as you can. So you really brought those masses really close together. So I think in the fact that we're building a mid-engine car means that we're okay with the polar moment of inertia being small. And you know, when you drive a small single-seater race car and it's got the engine right behind you and you feel how rapidly they turn, it gets pretty addictive. You want to have the same sort of thing in a road car, even though you're paying for that instability. So anytime the car's going to turn a little bit better,
Snap oversteer is always a risk.
yeah. So
That's a skill issue for the most part.
Yeah. So you just, there's a smaller window before it's going to lose it, and so you need to be a little bit more on top of your setup. And a lot of that you just can't do at the design time. So a lot of that you can get close. You can, if you're going to spend ages on your vehicle dynamics model, you can get it really quite accurate, but we're going to lack really good tyre data. I'm not going to put the effort into doing massive, complicated vehicle dynamics models for this project. I'm just trying to do the barest, like the minimum level to answer the questions that we need. So I'm just looking forward to when you get out on track and doing some spring damper tuning and having a play there, and maybe bringing some aero stability in. But I think polar moment inertia is really important. If you want something fun on the road, it's likely to be light, small. What was interesting when we did the mass one, that went out, that became so far the most viewed video on this channel. And with that, there were a few comments that you started to get a couple of negative comments that came through.
It's always one.
A couple.
Or a dozen.
I just sort of had to hide. I'm sorry if that was one of your comments and I hit them. It's just I've got too fragile an ego. But we would get comments like this from Michael Gurin. It was like, nope, you're wrong. That was the comment that was left. And I'm assuming that was because he wasn't happy that I said that 50-50 weight distribution wasn't ideal. Yeah, look, I might be wrong. If you think I'm wrong, you can go and do the work. That's fine. Like at the end of the day, this car's going to be a lot of fun, either which way we do it. But I would say with this sort of stuff, having the ideal weight balance, the ideal spring rates, ideal just about anything is so situation specific that the ideal weight balance on one racetrack will be different to ideal weight balance on another racetrack. And maybe in a future video we'll look at some lap time sims and a bit of optimization. It's actually an area I did my PhD in and did a bit of work. So big chance I'm wrong.
Comes back to what we said before, right? Wrong by what metric?
Wrong. I think Michael indicated by every metric I was wrong.
Well, perhaps Michael should be buying the Model 3.
So no, feel free. Like, it's okay to disagree with this stuff. We're not absolute experts in every single area. There's some things we feel pretty confident about, but always with anything, put the stuff to the test. So whatever we're saying, test it out. If you're reading it something different somewhere else, work through it. That's how engineers do things. We share knowledge and we work through assumptions. So it's okay to be wrong. In fact, when we do design reviews, how often are we wrong in design reviews?
I'm mostly wrong.
Yeah. Oh, the way to build a good car is to be wrong right up until you're right. So that's okay. Welcome on board if you're still watching. So another comment on the mass video, the location of the mass center. One of the comments, so Murray Madness posted, only comment that with an electric car you have a large ability to move the mass around because of battery placement. What do you think of that?
Well, we kind of talked about that before, with the polar moment of inertia and mass question. So you do have that ability to move the battery around, of course, but it comes with significant drawbacks.
Yeah, that it's heavy.
That it's heavy. The vehicle weighs a significant amount more. So things like your tires are going to be working a lot harder. Your battery is going to expend a lot more energy moving the mass around. So I would say in the case of an EV, particularly something like one of the modern EVs with modern safety systems, the drawbacks probably outweigh the optionality that you would gain by being able to move that mass around. But I have certainly seen designs from companies like Land Rover where they design the pack to sit in the bottom of the car in order to keep that COG low. So there are benefits for sure.
Yeah, I think from a vehicle dynamics point, there's so much you can do when so much of the mass can be moved around. So we mentioned in that video that it's very difficult when you're going through the design process to actually get a mass location where you want it, even if you know exactly where you want it, because a lot of the components, once you've placed them, there's not much you can move it. So I would love for the center of mass to be around 55% rear, but it's going to be closer to 60% on the rear. And short of adding ballast, I can't do that. But if it was an electric car, you'd be able to hit it right on the money for that. So yeah, it gives a lot of options. And I don't think we've seen the best versions of electric cars yet. I don't think we've seen them really take advantage of that. Certainly they're getting it with the low center of mass, but there's a lot that can be done there. I think the thing we've got to be careful about though when it comes to building electric cars is that we're not necessarily making it easier. It's not easier to design just because one aspect is easier. So I like to think about it as the electric motor is a lot simpler than a non-IC motor. But the electric fuel tank is a heck of a lot more complicated than an IC fuel tank. So the work is different. You're not putting it necessarily in the engine, you're starting to put it in the batteries, and there's a lot of work that can be done there.
Yeah.
And you've done a little bit of this in your professional space not with cars, but electric trains.
Yeah, locomotives. The problems existed in the 70s with Porsches, with fuel tanks. They had, the car would handle one way with a full tank of fuel and completely differently when the tank was empty. So this is a problem engineers have had for a significant amount of time.
Well, it's funny you mentioned Porsches, Harley, because a number of people in the comments for this asked, what do we think about transaxles? And in particular, the transaxles in Porsche, so a 924 or a 944. What do you think about transaxle Porsches?
Well, my personal opinion is a little bit tainted by our experience with our 924 from some years ago. But I think broadly speaking, they're brilliant pieces of engineering. For mid-engine vehicles, they're great. They offer all the optionality of having a gearbox and differential combined into one component. And similar to an EV battery, you've got a lot of control over where that mass is. Specifically, it tends to sit low and towards the center of the vehicle. So a lot of advantages there. Yeah,
full disclosure, if you haven't followed all of the videos, we worked on a 924 together. We bought a car that was not running. It had an okay paint job. We did a lot of work to get it running, and it needed a lot more work to take it to the next stage before we sold it. Happy to see it go.
With most things in life, though, it's better to leave them better than you found them, and I think we achieved that.
Yeah, just. But I think the reason we bought that is, we were interested in the handling of it. It was a transaxle car. We were pretty interested. That it was not fun to work on though. I think the advances since the 1970s have really been noticeable.
Yep, certainly.
Okay, another area that got a few questions was the windscreen when it came to aero. So if you saw the first aero one, a lot of noise, a lot of turbulence was coming straight at the driver's head, which was exactly what we're trying to avoid. We try to keep this really nice, short windscreen.
That's what helmets are for.
Yeah, I don't want to be wearing a helmet all the time driving this. Maybe some old school British driving goggles.
Big goggles, yeah, I could go for those.
That driving cap.
Yeah.
And the suggestions of maybe add a bit of height and asking questions what you're going to make it out of. Look, there's a bunch of that we've got to go through ICV, so we've got to go through the regulations for that. I think up to a certain height, you can run a plastic-based windscreen, but there's big problems once you start to want to do that in glass, because you just got to find the shape. It's really hard to actually make glass.
Custom glass is very expensive.
Yeah, I don't even know if there's anybody in Perth that does it. I think
not curved.
No, and I think we would have to, go further afield, and that windscreen to try and get the shape we want is going to be very expensive. So I think if we were able to do that in a plastic and sort of heat it and put it over a mold, we could use a CNC router to make some of the mold parts. That's the preferred method. But we've just got to try and make that work aerodynamically, because if the head's sitting in that turbulence all the time, that's not going to be fun for anyone. So, do you have any further comments on the windscreen?
No, the driving experience is what we're going for here. So if we ruin that with turbulent air in your face, then what was it all for?
Yeah. And I think around that driver experience, somebody posted here, so Magnus Danielson posted, good discussion, but what about driver comfort? The leg position looks terrible. And I didn't know whether I'd stuffed something up in the model or whether they're just saying the leg position as it's shown is terrible. But we've built a mock-up here. Do you think the leg position's terrible?
Well, I was going to say, I'm not sure if the viewers are aware, but we actually built the ergonomics of the chassis in MDF. And a big part of what we've been doing is you and I jumping in and out of the chassis and targeting that ergonomics seating position so that we are comfortable to spend significant amounts of time sitting there. So I think it's very easy to look at something in CAD or an image and say that's uncomfortable. But the reality is we've built a mock-up of this and we're optimizing for that as we go. So fair comment, but agree to disagree.
Yeah, and I think one of the things that maybe makes some of the CAD models, and the reason we do some of these mock-ups is, we grabbed the driver CAD model off GrabCAD, and I've done a scan of me, and I was looking and I started building a driver model off that. But the CAD stuff, you're doing it as rigid body dynamics, and the human body actually sort of moves a little bit. So what might look uncomfortable in the CAD is not uncomfortable in the mock-up, and that's why we've been doing the mock-up. It was originally just an ergo mock-up, so not uncomfortable. So just for the final question, I think this is a bit of a thought experiment. This is from Jai Mo 6893. Dr. Kev, what would you do differently if money was no object in this build?
Well, if my name was Dr. Kev.
Oh, Professor Harley.
Professor Harley.
What would you do if money was no object?
I think it's actually a fairly easy one. I think I would do the same thing, just faster.
Yeah.
Ultimately, there's questions like powertrain and other configurations, i.e. a secondary vehicle, but I think it would be the same thing. We'd build this vehicle and then we'd build another vehicle.
Yeah, you'd keep going, wouldn't you?
You'd keep going. So I think it's fairly easy to answer.
Yeah, I think speed. I think you would go, okay, there's parts of this project that are likely to be less enjoyable than other parts. I'm just going to outsource that. I get more of a team. And I thought of this, I put an answer there, and I thought about speed of this, but if we'd just open it up and said money was no object and we were a manufacturer of these, what would you do? Is well, one, I wouldn't have another job. I'd be just working on this. There's so much work to be done. And second, I like some of the mates that I'm doing this with to also not have to have another job, and we just get to work on this full time. That would be absolutely fantastic. Things would happen a lot faster. You'd be able to get the equipment you need, so CNC equipment and that sort of thing. But in terms of what would it mean to the actual car, I don't think much to the end product.
The design philosophy would remain the same.
Yeah, I think that if we want to put carbon fibre in this car, we probably will. We'll find a way to pay for it. Engine-wise, for the first car, you're not going to do something crazy like a full custom-built engine or anything like that. So I'm not sure that the actual concept of the car would change. It's just we'd have a lot more toys to do it with, faster computers, that sort of stuff. And I think with a lot of engineering projects, that's the same. You trade money for time. You get the thing out earlier.
Yeah. The only thing that I would do differently is speed.
Yeah,
that's all I can think of.
I don't think there's been a case where, I mean, maybe there's small things where you go, maybe instead of the wheels that we got, the Enkei wheels, which are absolutely fantastic, you'd spend a little bit extra, a lot extra, and you get ones that are a little bit lighter. That would have a very minor impact on the overall car concept. So we might go from sort of 600 kilos and drop like 10, 20 kilos just by choosing the lighter option.
Probably some more additive manufacturing, some sintered metal parts, things like that.
Yeah, but even that's pretty accessible. These days you can go and order that stuff from manufacturers, and it's...
Yeah, but we would have ordered them 6 months ago.
Yeah. Well, I think actually the thing that sort of goes along with that is you'd be less worried about mistakes. So a lot of the time that is going into this, so in the design, the small amount of design time that we have, when your resources are limited, so when your time is limited and your money is limited, you have a really low tolerance for making mistakes, because any mistake is just going to cost you time, it's going to cost you money. So you need to be a little bit surer that something's going to work. Whereas if you have a lot of money, so if we're, say, choosing the tyre, you'd say, well, it doesn't matter, we'll choose 4 different tyres and we'll test them on the final car. So we just can bypass a lot of that decision making.
Money is a proxy for time. If you have infinite money, you have infinite time. It's a good question, but it is essentially money equals time. That's all. Our time is money, but our time is finite. If we had more money, that means we have more time from other people. So it's amazing. I guess what I'm saying is it's amazing how direct the correlation actually is. Like it's basically 1 for 1.
Yeah. You just got access to better tools and things like that. And yeah, it's a nice thought experiment. But generally, when we've done stuff at the uni and you're designing cars, it's very rare that money is the thing that stops you, because the raw materials, they're not that expensive. Not really. Even carbon fiber, it's expensive if you're trying to compare it to fiberglass, but the actual real cost of doing that stuff is more the time you put in. So it's the cost of all your molding and equipment and everything far exceeds the cost of the actual materials. So I find generally with cars, you can be quite exotic with what you're doing as long as you are doing the building.
Yeah, money can buy you convenience. For example, you could pay designers, but at the end of the day, if you want to design a sports car yourself, it doesn't make sense to pay someone to do it for you.
Yeah, I mean, if you look at an upright, we're probably going to make the upright and the suspension out of billet aluminium. A billet of 6 series aluminium, it's not that expensive. Even 7 series is not that expensive anymore. And if you really want to, you can machine that stuff with a hand router. I mean, it wouldn't be fun, but you could do it. So the material is not going to cost you. It's actually the equipment and the processes around that. We're fortunate that being in and around engineering, you tend to meet a few people. So, you can ask people for help. And if you don't have access to a piece of equipment, somebody else might. So your budget is somewhat extended by who you know, just because they might have a tool. So great thought experiment, but I don't think it'd make me any happier. I don't think it makes the project any more enjoyable.
Yeah, I agree.
Yeah, so that's what we do. If money was no object, we'd probably give up our day jobs and just build cars, and we'd move from this car to the next car to the next car and just keep going. Having fun. Sounds like good life to me.
Yeah, we get this content out a lot quicker, I can tell you that.
Yeah, you'd see more if we had infinite money. Or maybe we wouldn't even need YouTube. I don't know. Make the comment about that. If we had infinite money, would you even see the videos anymore? But look, thanks for joining us. It's been really good. We love going through the questions. We can't even come close to answering all of the comments that are there, especially recently. There's been a lot more comments. So if we missed something that was really a burning question for you, I haven't responded to it in the comments, apologize for that. But comment on this video and say, what about this comment? We really should answer this next time. And we do plan to be back here in about a month from now and do another one of these videos. So
yeah, and if you want to see more of this content, like, comment, subscribe, hit that notification bell, engage any way you can. It helps us.
Thanks for your time.